Cris Whitman, architect, and I'm the coordinator of the Laboratory of Energy and Lighting of the Faculty of Architecture, Art and Design. This semester I'm working with the students of the laboratory practice in industrial design, and we're looking at the installation of 3 photovoltaic panels in the facade of the machine workshop. My interest with solar architecture and solar energy is basically because here in Chile there's problems with not enough energy. Chile has to import up to 60% of its primary energy, but it has a tremendous resource which is solar energy, which at the moment it's not really using to its full potential. So whenever possible I like to involve the students in solar power so that they can understand that this is a resource which is theirs and which really they should be making full use of in the future. The system that we're installing is basically the same as what's installed on the library building, but an awful lot smaller. Probably the biggest difference is that we're going to have batteries because the system there is connected directly to the electrical circuit of the university, and because the university uses more electricity than they actually produce with the solar panels, they never need to store any. Whereas here, because we want to make measurements of how much we're actually producing and how much we're using, we want to have batteries to store the energy and make those calculations. But the other elements are exactly the same. The photovoltaic panels, these polycrystalline panels, whereas the one are monocrystalline on the library. There's solar charge controller, which they also have over there, and an inverter, because the panels produce direct current, and what we need to use for the majority of electrical appliances is alternating current. So that's necessary to have that. The students at the moment are working on a design which will be the mounting of these 3 panels so that we can orientate them with the correct angle and the correct orientation to the north, and also something that will be an interesting element on the facade and not just 3 panels stuck on there. The cost of the overall system with the batteries, the panels, the inverter and the charge controller was around 1 million pesos. That doesn't include the wiring necessary to connect it all, or the materials to actually mount the panels. And also the students are going to be doing a display unit so that we can actually see how the whole system works. And in the future we want to buy a monitor to actually measure actually how much we're producing. The system which is installed on top of the library, that actually has a monitoring system which is connected to the internet. I'm not sure if it's actually working yet, but the idea is it's going to be possible online to see how much electricity it's actually generating. The support that I've had from the campus authorities and the university authorities, well, firstly for actually buying the solar panels and the battery and all the equipment needed, although the students are actually buying the material to actually mount the panels. We also had meetings with the administrator of the campus to present our ideas to them so that we could get their feedback. Their biggest interest was how much does it cost as a system, thinking how they could manage to implement it in the future, which I think is an encouraging sign. In my opinion, the project is easily applicable to the whole of Santiago. Really, I think that every institution and every house should have its own photovoltaics. producing electricity. With the new law that exists, which will allow people to actually sell electricity to the distribution network, this will hopefully increase the amount of panels and it will be an idea that people buy panels in order to sell electricity. Unfortunately, the small print of the law looks like it's going to be that the electrical companies buy the electricity for a smaller amount than they actually sell it. So it won't be quite as big a business opportunity as it has been in other countries such as Germany and in England and in Spain, where there's actually subsidies that the companies have to pay up to 2 times or 3 times the actual cost that they sell their electricity, so that actually people start renting space on roofs of other buildings or sports arenas in order to put the panels. And this is a way to actually really increase the size of the photovoltaic industry.